Hello my dear students, welcome to another session of Amazing World of Science, and today we are going to continue with class 10 science second chapter, and we have already started it and learned from acid, bases and salts. Today we will continue from where we stopped yesterday. That is, yesterday we were learning about the reaction of metallic oxides with acids. I hope you all understood whatever we learned so far very clearly, and you followed all the basic equations which I have taught you, and do write it in your book and revise those portions well. So, already we just learned about the reaction of metal oxides with acids, and we saw that when metal oxide react with acid, the products are salt and water. Now, let us see what happens. See, here you are asked to write and balance the equation. Already I have taught you how to balance the equation, and also another thing is that metallic oxides react with acids to give salt and water. So, similar to this reaction of a base with an acid, metallic oxides are also said to be basic oxides. So, just remember this point. Now, let us see the reaction of a non-metallic oxide with base. So, already we saw the reaction between carbon dioxide and calcium hydroxide, that is lime water, in previous activity. So, as you all know, calcium hydroxide is a base and it reacts with carbon dioxide to give you salt and water. So, this is similar to the reaction between base and an acid. So, we can conclude that non-metallic oxides are acidic in nature. Just remember, metallic oxides are basic in nature and non-metallic oxides are acidic in nature. So, based on this you have got a few questions here. So, do try to answer these questions, and we will discuss these questions at a later separate session. Okay, now let us move on to the next topic. What do all acids and bases have in common? So, you have seen in the previous sessions that all acids have similar chemical properties. Why do they have similar properties? What is the reason for that? So, you saw that all acids will give hydrogen gas on reacting with metals. That is, when acid reacts with metals, hydrogen gas is given out, and hydrogen is common to all acids. See, whatever acids you take, hydrochloric acid, nitric acid, sulfuric acid, all these acids have hydrogen in common. So, we will perform one activity and see if all compounds containing hydrogen are acidic. Does this mean that any compound which has hydrogen, is it acidic or not? That is what we are trying to find out through this activity. So, what you have to do is take solutions of glucose, alcohol, hydrochloric acid. Okay, take solutions of glucose, alcohol, hydrochloric acid, sulfuric acid. Now, you just fix 2 nails on a cork and place the cork in 100 ml beaker. So, we have got the figure here. See, this is a beaker 100 ml, and we are having this nail. See, this is a rubber cork, and this is the nail. See, and dilute HCl solution is inside this, and this is connected to a battery, and the bulb is here. We have got a switch also. Now, what have you got to do? You are connecting the nails to 2 terminals. See here, 6-watt battery. This is 6-watt battery. You are connecting the 2 iron nails to 2 terminals of a 6-watt battery, and already we have poured some dilute hydrochloric acid in the beaker. Now, when you switch on the current, what can you see? And repeat the same experiment with sulfuric acid, and then repeat it with glucose, alcohol, and see whether the bulb glows in all cases. So, what you can see from this activity is that the bulb will start glowing in case of acids alone. Okay, and but you will observe that glucose and alcohols do not conduct electricity. That is, because they do not conduct electricity, the bulb will not glow with glucose and alcohol solutions. So, what does glowing of bulbs say? It shows that there is a flow of electric current through the solution. What solution was it? It was hydrochloric acid So, the electric current is carried through the solution by ions. So, how does the electric current move? Because it is ions, so ions will move in the solution, which is the way electric current is carried through the solution. And you know that cation, positive ions are called cations, that is present in acids, that is H plus. What does it say? It suggests that acids produce hydrogen ions, H plus ions in solution, which are responsible for their acidic properties. Because of the presence of H plus ions, that is why the acids, that is the reason for the properties of the acid. What is the reason? The presence of H plus ions in them. And when you repeat the same activity using alkalis like sodium hydroxide, calcium hydroxide and all that, you can see that they do not conduct electricity. Now, what can you see next? We will see what happens to an acid or base in water solution. Okay, so do acids produce only ions in aqueous solution? We will just test this. Okay, now what have you got to do? You take 1 gram solid NaCl, NaCl is a base, in a clean and dry test tube. Test tube which you conduct the experiment should be always clean and neat. Then you have to add some concentrated sulfuric acid. See here, sodium chloride we have taken in a clean test tube, and you are adding from a conical flask concentrated sulfuric acid. Fine. Now what do you see? Is there any gas coming out of the delivery tube? See in this setup, see we are closing this test tube with one whole cork, and which is having a delivery tube. Now what does it say? Test the gas evolved with dry and wet blue litmus paper. And you know the litmus paper, it is an indicator, already we have learned about it. And in which case does the litmus paper change color? So you know the acid medium and basic medium can be detected by the test using litmus paper. So based on this, what do you understand about the acidic character of dry HCl gas and HCl solution? Okay, so this experiment, what can you see from this? That is, this experiment says that hydrogen ions in HCl are produced in the presence of water. So the separation of hydrogen ions from HCl molecules cannot occur in the absence of water. This is a very important point, note this. Okay, so H plus ions from HCl we cannot separate it in the absence of water. See, HCl plus H2O gives, see this H gets added to this H2, H3O plus Cl minus, it becomes ions. Okay, H3O ions and Cl minus ions. So hydrogen ions cannot exist alone, but they exist after combining with water molecules. See, H2O, H plus cannot split and remain alone. So instead it combines with H2O and becomes H3O plus. So hydrogen ions must always be shown as H plus in aqueous or hydronium ion, that is H3O plus. So always that is the way which we show hydrogen ions. So see how it is formed, H plus plus H2O gives H3O plus. We have seen that acids give H3O plus or H plus ion in water, and we will see what happens when a base is dissolved in water. See, NaOH, when it is dissolved in water, it splits into sodium ions and OH, hydroxyl ions. Okay, Na plus and OH minus. Clear? So just revise clearly, because every class I am taking only very little portions, because it will be very easy for you to read it repeatedly and get the concepts clearly. So it is a very important point that you have to get the concepts deeply, only then you will have a strong foundation for chemistry and you will find it easy at the next level. So I hope all this is clear for you today, and I will be coming up with the next part of the lesson in our next session. And do like, share and subscribe to our channel Amazing World of Science, and do share it with your friends, and do support us, and we will learn together. Okay, thanks for watching.